This conference will now be recorded.
Okay. Important to communities, including First Nations, Inuit, and Indigenous communities. And we also know that they're linked to better nutrition and individual health versus store-bought foods. So lower hypertension, diabetes, other such illnesses have been found to result in diets that are more inclusive of traditional foods versus those higher fat, sodium, store-bought foods. And then we're also looking at this from a lens of food sovereignty, which is the concept that First Nations communities have rights and title and access to those traditional foods and lands, and that these access build on healthy interdependent relationships with the lands and the communities. So knowing that context, then we wanted to look at how climate change or environmental change or social stressors could impact the access and availability of those traditional foods. So things like the impact to land or the habitats of food sources from wildfires, poor air quality from smoke that can impact people's ability to get out there and harvest, or really just the wildfires themselves that are impacting the land base or floods. Restrictions, and whether these are restrictions that are put in place by the First Nations themselves. So if you think about the Williams Lake area after last year's wildfires, the Chilcotin implemented a moose hunting moratorium. Even though that was a factor that was put by the community, it was still an impact to the access to those traditional foods. We also know that there's regulatory restrictions that can access traditional foods. So things like food from approved sources and the food premises regulation can restrict access in childcare facilities or in licensed facilities. There's costs associated with harvesting traditional foods, and gas costs and getting out there, or ammunition, or even vehicle availability to go out and harvest. So all these aspects can impact what we've recognized is a healthy, both socially healthy and physically healthy means of nutrition. So that brings us to why we're talking about this today. We know that these foods are important for those reasons I mentioned. We know that there can be impacts to accessing those important foods. And what we wanted to look at was how climate change specifically, or modifications to food harvesting and processing techniques based on climate change could impact that. So traditional food preservation practices have been effective since time immemorial. These are the foods that Indigenous populations consumed and lived off of for forever. So we knew that worked, but we also knew that based on climate change or based on environmental stressors, there is likely changes and adaptations to these practices that could introduce food safety hazards. And that climate change could reduce the effectiveness of natural methods of food preservation that were traditionally understood. So all of our case studies were based on input and conversations with both First Nations as well as Inuit communities and the environmental health professionals who work alongside them. So it's really a natural and organic way that this came about. And then we built upon that with some specific asks and knowledge holders to increase the scope of our work.
So I want to turn now to our first case study, which relates to smokehouse construction. Smoking is a form of food processing that's used on a wide variety of foods in Indigenous communities and elsewhere, such as fish, moose, deer, and birds. And historically, natural materials would have been used to construct these smokehouses, like tree boughs. But EHOs have seen smokehouses built with polytarps and canvas in several communities. Mostly this is because they're readily available, these materials, and they're easily manipulated around frames. So they're perfect in some ways for building smokehouses. But concern has been expressed about exposing these materials to heat in close proximity to food and how that could potentially lead to contamination. So that led to this specific inquiry that framed the conversation, which is what are the risks of the associated risks of using polytarps and human-made materials in the construction of smoking apparatuses. There wasn't a lot of literature on this specific topic, and so we decided to expand the scope to include the considerations of polycyclic aromatic hydrocarbons, or PAHs, in all smoking activities so that we could offer a bit of a broader perspective on this potential contamination risk. So there are indeed some clear impacts from PAHs, and the first part is that they are known carcinogens, and the impacts from these carcinogens can be both acute and long-term, and some of the short-term impacts from exposure are nausea, vomiting, eye and skin irritation, as well as breathing problems, and long-term it can be a severe kidney and liver damage, as well as DNA damage. When it comes to smoking foods and PAHs, the literature found that meats directly in the path of smoke had higher levels of PAHs, and fully smoked meats similarly had higher levels. Hot smoked fish, in particular, had much higher levels of benzoapyrenes. And it's also important to note that there are potential health risks for those individuals who are directly exposed to the wood smoke and poor air quality in those smokehouse conditions, which can happen when someone is working in the smokehouse and trying to process these meats as an individual. There are a few ways that we can reduce exposure to PAHs that I want to touch on quickly here. First, increasing the distance between the smoke and the food is the first step. It's also slightly beneficial to slightly smoke foods rather than fully smoke them, just to kind of reduce the exposure overall. If possible, smokehouses should not use treated lumber or galvanized metal for roofs, just so that those parts of the smokehouse are not the hottest parts of the smokehouse. You want to avoid chemical contamination by removing those types of materials. And it is important to remove oil and preservatives from metal that might be used for drying racks in the smokehouse, because they're also a part of that construction that comes into contact with food. And finally, to address some of the possible occupational exposures, it is important to ensure that there's proper ventilation that can reduce worker exposure in the workspace itself.
So our next case study is looking at the use of non-traditional materials to build planters or garden beds. It's kind of common sense that if you grow your own food, then you can increase your food security at a community level, not quite as much at the individual level, but certainly when communities come together and are looking at broad-scale gardening projects, and it really increases the nutritional availability of foods as well as the food security of those communities, and reduces your reliance on store-bought foods that can be more expensive or less attainable, especially for rural and remote communities. And as we mentioned kind of at the stop, we know that accessing grown foods or traditional wild foods are just naturally healthier. The concern, however, was that when we're talking about big garden projects, that garden beds might not necessarily be constructed out of easily accessible wood or plastic or gardening bed materials, but that there may be a reliance on more easily accessible or on-hand waste materials that are non-traditional. So this specific inquiry is looking at the use of old used tires as planters. So you change tires out on your vehicle, you have a bunch of these laying around. Maybe one of those tire recycling depots isn't easily accessible to you, and this is seen as a convenient way to repurpose them from waste into something that can lead to more food security. So looking at the literature, the use of whole tires, so whole rubber tires as planters, was pretty neutral. So nothing really stood out as a fundamental risk to that practice. There were maybe some increased risks if those tires were ground and chipped up. So of course that would lead to a greater surface area for any leaching that did occur. And then zinc from the wires within the tires. So whether that's the metal belt kind of between the layers of rubber in the tires, or that bead wire that kind of goes around the inside of the rim and stops the rubber from rubbing on the rim. So those have a high zinc content. And so depending on the pH of the water that's coming into contact with that metal, there could be some leaching and public health risk associated with that. And then just in general, having tires laying around, whether they're being used.
Okay, how's that now, everyone? Sorry. Can you hear us? Okay, thank you.
All right, taking it from the top. So recommendations for the use of tires as planters to reduce public health concerns. First one is using only whole tires, not the chipped or ground up ones. Checking regularly for exposed bead wires or belts that can contain that zinc that could leach into the surrounding water. Poor condition tires should be replaced or coated with a non-toxic sealant, and then replacing the soil in the tires annually, so rotating that out. And then after 5 years, if you are going to keep using those tires as planters, keep them to flowers only and not food crops, which can reduce any loading risk of contaminants into the surrounding soil.
So the next topic we're going to talk about is greywater for crop irrigation. The context for this inquiry comes from the fact that drought and reduced availability of irrigation water has been a big problem as a result of climate change and has consistently been highlighted as a concern for Indigenous communities. Greywater, just to give a little definition here, is water that's non-toilet household wastewater. And that kind of water and rainwater have both been discussed as potential alternatives to using potable water that reduces the stress on potable water demands in communities and also limits the treatment of other types of water that you might want to use to irrigate your crops. Greywater reuse systems are actually not common. In BC, for instance, legislation does not at all differentiate between greywater and black water, which is actually sewage water. So that's something that gave us a little context here to frame what was most important to identify for these communities. We did conduct a search to identify what the public health risks of consuming crops grown using recycled water were, and that was kind of how our specific inquiry came together. So there are a couple of concerns from using recycled water. First, black water is never recommended. It does pose a high risk for human infection, primarily from things like Salmonella and Giardia and Legionella. So that's definitely a big no-no, generally speaking. Greywater quality does differ significantly, though, depending on household. So it's a trickier matter to decide whether that's something that should be used for crops. When it comes to rainwater, the public often does perceive it as clean, in quotation marks, but it does often contain contaminants such as lead and copper, as well as potential human pathogens. So it should be treated before use, even if it's coming from the sky. The biggest problem is then that crops become contaminated either on plant surfaces when you're irrigating directly, or because there's been uptake into the plant tissues from the water in the soil, and both of those routes of exposure can be problematic when it comes to human health effects. There are a few ways to reduce risks from greywater use, and I'm going to go over them now. The first is to use drip irrigation, which is a good option to reduce contact with the plant material itself, and it does avoid evaporation on plant leaves. It does offer the lowest risk of contamination when it comes to using greywater that hasn't been treated, so I would certainly put that at the top of the list of things to keep in mind. Only using greywater in particular crops also helps because some crops like tomatoes and fruit trees are much less at risk because contamination doesn't actually travel to the edible fruits. Spinach and lettuce, for example, would be less appropriate for plants for greywater use, just because they do tend to come into contact with the water more, and the uptake into the plants is much higher than it would be into the edible fruits. It's also always good to assume that contamination potential is there for greywater, and therefore to treat or disinfect prior to consumption or use in food gardens. And finally, all water for domestic use should be tested regularly, both for compliance with relevant water quality guidelines and to test for any particular pathogens or contaminants that are thought to be present.
So the next one we wanted to look at was wind and sun drying of meat and fish. It's the traditional form of preserving foods in those climates that have low humidity and high winds and high ambient temperatures. In some of the communities I have the privilege of working with in the Fraser Valley, this is a really common historical way of preserving food for the winter. But of course, the risk is that The processes that have been placed for the last 10,000 years are focused on a specific climate, and as the climate changes, then the effectiveness of these traditional techniques might be impacted. So if temperatures change, if wind patterns change, if humidity in the air changes, then those traditional recipes and ways of doing things may be impacted negatively. So what we wanted to do is look at what the potential food safety risks were associated with wind and sun drying. And we made sure to expand this to include all of the mechanisms of wind and sun drying, not just the ones that I mentioned. And that way we could be sure that the evidence we looked at had some broader applicability. So food safety considerations, food spoilage was certainly one risk. So if the food wasn't adequately preserved, so either adequately salted, or if there's high humidity as part of the drying process, then the food could actually, develop mold before the drying was completed. Contamination of the raw product, so from chemical or microbial sources, things like the use of spoiled fish as opposed to fish that had been freshly caught, or contamination within the flesh of the fish itself from external sources, or from its presence in contaminated waters. Attraction of pests and animals and flies and those types of things throughout the drying process, and then contamination of the finished product, so unhygienic processing and drying or a lack of airtight packaging were kind of highlighted as the different factors where public health risk could come into play. The first recommendation that really stood out was the use of these solar dryers or an indirect solar radiation, which really reduced many, if not most, of those risks that I just talked about. So if you look at the picture there, it's an enclosed system. The food is removed from any direct contact with the atmosphere. So it limits the availability of that food to be accessed by insects or animals or other things that you don't want getting onto your food. It regulates the humidity. There's some designs of these solar dryers that actually have a bit of a stack that causes a downdraft and blows air over top of it. That can increase the speed of the drying and regulate the air humidity a little bit. It reduces dust contamination or any toxic metal accumulation that might blow from the surrounding environment onto the food. So from a food safety perspective, these things are fantastic, but of course the initial cost and availability of materials can be an impediment to creating a bunch of these. So if you look at building however many of these you need versus natural wood drying racks along the river canyon that would historically be used, there's a huge increase in the workload and amount of materials needed. And then there's also some additional studies that need to be done on the efficiency of viral inactivation using drying through these solar dryers. And then if you think outside the solar dryers, some additional recommendations that are fairly common sense. So during that preservation, make sure that you're using hygienic practices and the use of potable water to clean the fish prior to drying them. If salting is your process, making sure that there's adequate salt content, packaging things up in an airtight manner, keeping products on those racks and up off the ground, kind of out of reach of animals. And we know that the natural wind that might have been used in creation of Stewan in the Lillooet area would keep the flies off as well. The health benefits of traditional foods, we found that food dried using some of these traditional practices versus drying in ovens actually has some higher nutritional qualities. So higher protein content in the meat and fish, lower fat and lower saturated fatty acids. On the flip side of that, the oven-dried food had some reduced lipid content and increased vitamin A, and also had a longer shelf life, possibly due to the moisture content within it.
So this next case study is very reminiscent of the case that we looked at with the garden tires. In the case of garden beds more generally, Indigenous communities have expressed concerns about all sorts of non-conventional building materials, as Casey mentioned, and railway ties and treated timber in particular has come up, as they are easily accessible if a community happens to live near a railway line. In those cases, they're inexpensive or free because they're taken from the railway line, and conveniently or inconveniently, as you might interpret it, they're already properly sized for the construction use of these boxes. So they're certainly appealing because it doesn't require much effort to go and get these pieces of lumber that may be treated, and in many cases are intentionally treated with many types of chemicals. The scope of this specific query was expanded to include treated timber that was not just railway ties, but that was mostly so that the recommendations would be relevant to the greatest number of communities, because even those communities that don't live near railroads definitely have access to potentially discarded treated timber. So in this case, the inquiry was, what are the public health risks associated with consuming crops that have been grown in planters constructed from railroad ties or from treated timber? Food safety considerations from this practice is a result of a combination of three factors, basically. The first is that contaminants such as PHAs, arsenic, copper, chromium, creosote, boron, and PCBs can, in fact, leach into the soil. And the literature identified some specific risks from that kind of leaching that come up and have been shown to kind of accelerate some of the problems. So one is that hot weather does tend to increase the migration of PHAs. When the ties have been weathered, or when the timber has been weathered, there tends to be less migration of PHAs. There's consistently a correlation between PHA levels in plants and in the ties. So that's to say, railway ties that have higher PHA levels are also going to have high soil PHA levels. We see leaching in subsequent years of use of these different heavy metals. So there's certainly no evidence to suggest that using it for the first year and then just having it leach into the soil and not planting and then continuing to use it next year, thinking that the metals will have dissipated, is not correct. And some studies have actually found that there are still high levels of creosote in ties, specifically after 75 years of use. So it's not an insignificant leaching rate is the point here. The second factor that kind of contributes to this problem is that the greatest human consumption of metals results actually from eating root crops, so things like beets, turnips, carrots, potatoes, that have come into contact with contaminated soil, and it's because they're in contact with that soil throughout their entire growth cycle. The third factor is that opportunistic black yeast do grow and thrive on railroad ties, and that's because growth is supported by creosote if it's present, and that's fairly consistently present on all railroad ties. So these yeasts can be directly harmful to human health, so it's a third factor here that we want to keep in mind when it comes to food safety considerations. So going forward, some recommendations to reduce these risks. Contamination does rapidly decrease with distance from the treated material. So even though these materials do continue to leach into the soil over time, some studies have identified that there's often a distance limit for leaching. 20 years ago, that limit, based on the testing methodology, was a meter, but actually most studies now find that it's 10 centimeters. So if you're cognizant of planting 10 centimeters away from some of these materials, you might be able to reduce some of that leaching risk. Another way to reduce the leaching risk is actually to just install a barrier between the soil and that treated material that's being used. An example of this might be to paint the bottom of treated timbers. Several studies found that painting, again with something non-toxic, reduced heavy metal leaching into the soil by up to 75%. So that's not insignificant at all, especially if you're talking about a long-term exposure to soil that's been contaminated. And another physical barrier might end up being heavy plastic liners in the garden beds, just to make sure that bleaching is just considerably less possible. A final note on creosote that is used for these railroad ties is that it actually impacts plant growth directly and more generally than when it comes to contamination. It actually just inhibits food quality and yield. So avoiding railroad ties might also be a good idea when it comes to just having better crop production.
So our last case study came about as request for information after a climate change adaptation project in an Inuit community. So they had installed some hydroponics as a way to reduce reliance on expensive imported produce, and certainly, this is used in other areas as well, northern and remote communities. So earlier, you'll recall we talked about food security and how at the community level, gardening can lead to a sense of food security for communities as well as accessing healthier foods. However, in climates that aren't as appropriate for gardening, hydroponics are a good way to provide those leafy greens and those vegetables and those higher nutrient foods. So a little bit of background: hydroponics are just foods that are grown in the absence of soil, typically in a solvent like water, as well as a mineral solution that gives them all the nutrients they need. And then the roots are supported by an inert medium that it can be gravel or it can be coconut husk or something just to support the roots. We also know that climate change can have an impact on traditional means of transporting foods. So as I said, you can't necessarily grow them in some of those northern climates, so they have to be trucked in. If there's communities that rely on ice roads or those types of means of transportation, and even as fuel prices increase, that can have impacts on the availability and cost of consuming these healthy foods. So certainly some benefits to growing crops using hydroponics. And so what the request was is looking at the food safety risks associated with those processes to make sure that there wasn't any additional risk being implemented. So the biggest food safety consideration is the uptake of contaminants into those hydroponically grown plants. So Leela had mentioned how this can also be a concern in some of the soil-based crop growth, and equally into hydroponically grown. So typically in hydroponics, these contaminants would originate from the irrigation water itself. And what the literature showed is that it's a pretty broad scope of things that can get into the food product through that uptake. So everything from salmonella or human norovirus analogs, microcystins, hepatitis virus, and even pharmaceuticals. And then it was also found that, not just the irrigation water, but if you start the growth from contaminated seed, then that contamination can essentially grow into the mature plant. So recommendations to reduce those risks. First one is consider your crop. So as Leela mentioned, things like tomatoes and fruit trees, which are not going to be growing hydroponically, but tomatoes certainly are shown to be at a lower risk of that contaminant movement through the plant. And this is likely due just to the physical distance between the root to the fruit. So a longer way for those contaminants to travel to get to the consumable part. Use of clean irrigation water. So like I said, most of these contaminants are coming from the irrigation water itself. And of course, you're growing these things in the absence of soil. So you don't have to worry about contaminants coming from the soil. So making sure that you're using clean irrigation water, and kind of with all things, we recommend frequent water quality testing just to confirm that you are in fact using clean irrigation water. Use of good agricultural or good manufacturing processes. Again, just good advice in general. So these are things like making sure that workers are healthy and have access to toilet facilities, and are removed from the growth environment if they're not feeling well, and then reducing pest access to those food products. And if you know that the irrigation water is poor quality, then swapping that out for an organomineral nutrient solution can reduce the risks as well.
So we want to wrap up here just by highlighting some of the takeaways from each of these sections and kind of lumping them into three distinct groups. One of the most pertinent changes are physical interventions, which is to say that an easy and effective approach can actually be just reducing contact points with contaminants. And so from all these case studies, there are a couple of key ways that we can do this. Increasing distance between food and and smoke sources is a big one when it comes to smoking foods. We want to dry foods away from contaminant sources, so on racks, off the ground, away from dirt and debris and pest access. Again, as Casey just mentioned, we want to use hygienic practices when handling and packaging foods, so at every stage of the production process, but specifically when those foods are about to be sealed away. Use only whole tires and watch out for those exposed wires, so avoiding contact with those contaminants, once again, in a physical manner. Rotate the soil in garden beds that are made out of tires or treated timber or railroad ties, so leaching is interrupted physically. Avoid close contact between those materials, so putting in those physical barriers like paint and plastic, wrapping to contain soil away from whatever materials have been scavenged, and then avoiding the use of any of those treated materials after 5 consecutive years. So the last step of avoiding or of reducing contact points is actually reducing a contact point with something. Once it's outworn, it's welcome, as it were.
And then the next one is chemical interventions, so removing the contaminants themselves. So avoiding the use of treated lumber or galvanized metal in food processing, and then if you're using metals, making sure to remove any oils or chemicals from those surfaces prior to applying food onto them. In general, making sure that irrigation water or any water being used is potable, including water that you're using for cleaning and disinfecting things, so using adequate disinfection processes for your tools and your handling materials. If you are using salt as a food curing, making sure that you're adequately applying that treatment method. Avoiding creosote-treated items, similarly linked to the treated lumber or galvanized metals. And then in the hydroponics, as I mentioned, if you know that you're stuck with some poor irrigation water, using organo-mineral nutrient solutions instead.
So the last type of intervention here, technological intervention, relies on the use of specific equipment to improve food safety outcomes. Some of those examples might be that drip irrigation system that we mentioned earlier in terms of reducing contamination risks from greywater use. It also reduces contamination of fruits and leafy areas, reduces evaporation. So just installing systems like that can go a long way to generally bringing down contamination risks. Installing ventilation systems to reduce PAH exposure and provide safe work environments is a big one when it comes to food smoking. Water quality testing for hydroponics and irrigation water is a technological intervention, and it may not seem extreme, but it's certainly something important to do consistently so that there are regular results when you're deciding what water to use. And the use of solar dryers to reduce dust, lower the toxic metal accumulation in foods, and regulate humidity when drying foods are all important aspects of changing up how solar drying can be done. I do want to mention that purchasing, installing, and maintaining these types of technological systems is often quite resource intense and can definitely be beyond the financial resources of different communities. So it's something to consider, certainly, in terms of the realistic application of these kinds of interventions. But I also want to mention that implementing the systems can have the potential to increase food sovereignty overall, as well as food safety. And so there can be other positive impacts on the community from investing in these types of resources. And doing that kind of cost-benefit analysis is worthwhile when balancing the environmental health risks of these types of practices and also the potential benefits to food security in a particular community. We've basically gone over the big points here and went through this just to give everybody a snapshot, but I do want to point you to the full evidence review if you're interested. We've included a bit.ly link here so you don't have to write down the super long URL, but the evidence review is titled Indigenous Food Safety and Security Community Adaptations in the Wake of Climate Pressures, and it can be found on the NCCEH website. We've put that down on the slide as well, and if you do have any questions, we've put our email addresses on the slides so you can send us a note, but Tina is going to open the floor for some questions right now if you want to ask now, but do feel free to contact us at any time if you have more questions about this project. And thanks so much for listening.
Thank you.
Thank you. Okay, so as Leela said, we'll start with questions. If you have any questions, type them into the chat box and we'll get to them. So right now we have 2 questions. Leela, if you could open up the bubble, the chat bubble up there, if you see the orange one. Yeah. Okay, so we'll go with the first one that was sent to me privately, so I don't think Leela can see it. What is the number of food illness outbreaks in BC that have been attributed to consumption of traditionally processed food? I don't know if either of you know.
Good question. And honestly, I don't even know that it's necessarily that we don't know as much as it didn't come up in literature, and I would suspect that there hasn't been a lot of studies that specifically look at traditionally processed foods and the outbreak or illness burden associated with them.
Yeah, I would actually concur. So because I just worked on a few papers on ethnic foods for my own project, and there's a lot of data out there about foodborne illnesses attributed to certain dishes or certain foods out there.
Yeah, I would just to add on to that, it's certainly about being proactive in some of these cases too, right? I mean, these communities have expressed interest in furthering their own food safety and food security issues, and so I think that's almost in some ways a better reason to embark on a project is to be proactive about some of these things before there does happen to be an outbreak. And so getting these information to the communities that are interested is certainly a big priority here.
Okay, thank you. Next question. Is CWD, I'm not sure what CWD stands for. I don't know if
chronic wasting disease, maybe.
Is that it? It's not part of our...
Is CWD a concern in BC's First Nations, even though it has not been found near wildlife populations yet?
Yeah.
So it is a concern in the sense that it's being monitored. So there's surveillance programs in place. There's active programs to get that information out to hunters and have them aware of it. And then between the Alberta and BC borders, the governments provincially are keenly watching to make sure that it doesn't cross the border. So hasn't yet been identified in BC, but certainly the awareness is there. And within FNHA, we're keen as well to make sure that hunters have access to that information and know what to be looking for in their processes.
Okay. Do you have anything to add, Leela, to that? Okay. Next question. So you can see it there. Increased temperatures with climate change may favor local application of viruses such as vector-borne diseases, such as West Nile virus. Do you have any data on the prevalence of vector-borne diseases or waterborne diseases related to climate change? I'm thinking, but where you mentioned using tires for flowers versus fruit plants, and wondering if this is something that was looked at.
I would say there certainly is, I think, data on that, but it's outside the scope of what we were looking at because it is directly linked to some of these issues with food safety, but I think that's more a indirect consequence of using some of those materials rather than an issue that pertains to the food grown in those garden tires. So I would say that there certainly are resources that speak to that, and actually if you send me an email, I can find them for you, but it was not within the scope of this evidence review.
Okay, next question. What are the implications of slightly smoking versus fully smoking a food product in terms of preservation?
Very good question. And yeah, this actually came up in our paper as a factor of consideration. So the quick answer is it depends, but certainly in our paper we did mention that is a consideration for slightly smoking food. So while it may reduce the PAH burden, flip side is you want to make sure that the food is being preserved to either a shelf-stable standard or to reduce the disease burden there. It's another one of those trade-offs.
Okay, thank you. Next question. When they increase the distance between the smoking and food, how does this affect the temperature and time for proper smoking, as the distance would affect the temperature?
Yeah, that seems like one of those things that you're trying to balance as well. So if you are trying to reach a particular temperature, and the fastest way to do that is to have a higher heat, but that higher heat does tend to release contaminants from these metals or different pieces of plastics or wood that's in the smokehouse. There's certainly no guideline on a specific way to avoid that, and using best judgment in terms of keeping food away from those contaminated materials is really the best information that we have at this point, is to say that there is contamination potential, balance the risk of that contamination potential with the risk of not fully cooking your foods, I wish that there was something more specific that was out there, but because this is kind of it's kind of an evolution that is progressing in these communities, and they're trying different ways to adapt those practices that might have consistently been at the same temperature for however many years those communities were doing it. It's something that I think should be looked at in more detail, but unfortunately we don't have any real concrete evidence about how you can change your drying time to be exactly the right drying time for this particular meat. I mean, I think that people are still working on trying out those different options right now.
Yeah, I think the best advice is increase the distance as much as possible while maintaining the time and temperature and heat levels that you need to properly cure the food.
Okay, so next question about recordings being posted. Oh yes, we'll be posting. I try to post it within 3 days or so, so end of this week should be posted. Okay, so next question. I am using the rainwater collected from the roof of my house. I am using drip irrigation to irrigate my plants, especially the trees in my garden. My concern is about the chemicals that may leach from the shingles of the roof. Are there any studies indicating that these chemicals could be absorbed by leafy plants or trees?
There's a couple of things that jump out to me here. First, if you can establish whether the chemicals from the shingles are actually leaching, and that has a lot to do with contact time as well as temperature. So in a rain situation, it's not likely to be super hot outside, but at the same time, I don't know the condition of the shingles on your house. So if these shingles haven't been replaced for a very long time and they're already degrading, that might also increase the contamination risk into the water. But again, the amount of time that the water is touching the shingles might limit that. So I think that's something to consider. Generally, though, I think, as the literature suggested to us, if there has been contamination, it's very likely that leafy plants will bring that up into the plant tissues. If you're talking about trees that are ornamental, it's less important. But if you're talking about trees that produce fruits, that is less likely to carry over that contamination. They just don't make their way all the way to the edible fruits generally. So it's kind of a couple of different things going on here. And I would advise that generally any kind of gray water, even if it's rainwater that hasn't touched your roof and has come into your rain barrel directly, or your rain barrel has been checked for any contamination potential, I would still treat it as potentially contaminated and use drip irrigation the way you're doing it, and use it on those plants that aren't necessarily going to be able to bring it into the tissues that you're eating. So that's kind of like a broader answer to all of those bits and pieces.
Yeah, totally concur. So the two pieces are, one is they're leaching from the shingles, or really any contact point between coming from the sky and getting to your plant, and then two, could it be absorbed into the plants themselves? And I think Leela's advice is fantastic. And if you stick with irrigating trees, or some of those plants where the consumable part is further from the roots, then those risks can be slightly mitigated.
I'm seeing the follow-up question to that on the screen. I'm just going to reply to it now before the next one. Bravo on having new shingles on the house. If it's imparting red color into the water, though, that does suggest to me that there's something going into the water, and red color in particular. I have this feeling that it's cadmium, because that's often used for red coloring. It could be a whole host of other heavy metals as well, though. So I'd be very careful about using water that you can visually see has been contaminated. I would steer clear of that if possible.
Okay, thank you. Next question. How does FNHA respond to communities wishing to prepare and serve traditional food in public facilities?
Great question. I think the first question is the definition of public facilities. So certainly our intent is to increase access to traditional foods. And so what we do is look at it from an evidence base to reduce any public health risks with the serving of those foods. So if we think specifically of Head Start programs or child care facilities, what we can do is work closely with communities from field to fork to identifying, in a HACCP manner what those specific issues might be, and how they can either be mitigated, or more specifically, how we can actually do a hazard analysis to identify that it is safe to eat fully along the process. So really, it's a matter of being closely involved with communities and working alongside them to provide that Western scientific evidence / knowledge base to what we know historically and traditionally is a safe product.
Okay, thank you. So next question is about the risks of particulate contamination on traditional agricultural food growth, processing, storage, or consumption through air.
Sorry,
air
the
pollution. Particulate contamination through air pollution.
As in, so can I ask for clarification? Are you referring to things like PM 2.5 in the air? Like if there's high levels of general like urban air pollution or wildfire smoke?
Yeah, I think so. The full question, they had some background. Sustained heavy smoke inversion layers in their community, and they're wondering about the risk of particulates from that.
Not knowing anything about that specifically, my tendencies, if you're talking about heavy smoke layers in the air, is that if it's problematic for your lungs to breathe, it's especially problematic if you're going to also consume it. If it's at a level where there are already issues for respiratory health, I think that those particles are going to adhere to whatever is available to them, and that kind of reinforces our recommendation to use solar dryers to keep the outside atmosphere away from the food materials, but we didn't specifically look at that, so I don't want to commit to a strong answer one way or the other, but in terms of wildfire smoke, depending on the region, that can certainly be problematic for contamination of all sorts of different things, so I think that's certainly a risk to consider for sure.
Okay, if you have any more questions, feel free to...
So yeah, Ryan's question, any evidence of leaching from PVC pipes in hydroponics? No, that didn't show up in literature. And one of the reasons for that is the lights are, or the pipes are specifically enclosed to reduce light. So one of the reasons for that is to not have mold or algae growth within it. But I suspect that also, reduces any small risks of leaching that may be there. So no, nothing that came up in literature.
I would also add to that to say that if there were some leaching from PVC pipes, I have the sense that hydroponic water is circulated quite consistently, and so uptake is a factor of how much of the contamination has actually stayed in that water that is being brought up through the roots. And if the water is being rotated and it's certainly not often kept at room or warmer temperatures, those are both going to be factors that reduce any kind of uptake from potential leaching. So I do suspect that there is leaching generally from PVC into water, but the conditions in hydroponic grow spaces might be such that it's not as much of an issue as other contaminants in the water.
Okay, next question. What areas were these case studies conducted? Just wondering if traditional food prep and storage that rely on refrigeration and permafrost may be affected.
So the majority of them came from within BC, and then we also reached out to our contacts within the First Nations Inuit Health Branch to identify some of those cases that might be non-BC related, which is where the hydroponics one came in the Inuit community. We didn't look at the permafrost related factors and how those might be impacted by climate change, but yeah, that's a good one for sure.
I think that kind of opens the door to the fact that there are a number of other traditional food preservation and processing techniques that were brought to our attention, and we just couldn't fit in more than 6 in this length of an evidence review. But certainly a number of communities have reached out and said, this is great, we have 3 more questions. So that's actually a fantastic question, because we did have some feedback from FINIB talking to us about Inuit food concerns being quite different from these food concerns. So that's a great flag to have raised. I thank you for that question. Could it be pollen?
I think it's related to the shingles.
Oh.
The red color.
Could be, yeah.
Okay, so that's the last of our questions. If you have more questions, feel free to email Leela or Casey in the near future. And thank you very much for joining us. And thank you to Casey and Leela. And have a great day, everyone.
Thanks very much.
Thank you.